From what it is to why it's so bizarre, join us as we explore Mira, the strangest star in the universe. In the universe above, there are many, many kinds of stars. There are ones that shine brighter than any other out there, and there are some that are so dim that you won't be able to see them unless you're very close to them. Some stars become black holes, and some become neutron stars that are arguably scarier than black holes. Regardless though, there's no doubt that stars make up a large part of our universe, which is why when it comes to the star known as Mira, it's a strange one. Why is it so strange compared to all the other stars in the sky and the universe beyond? Because it is technically a falling star, which I'm sure gives you all sorts of imagery, but it's not exactly what you think, and yet it's kind of what you would expect. Let's start with the basics, shall we? Mira, as it is known, is a star that is 700 times larger than the diameter of our own Sun, which makes it quite sizable when you consider that our Sun is 865,370 miles in diameter. That's not a small star, which makes Mira very massive in comparison. As for when we found this very unusual star, that would be 134 BC via the astronomer known as Hipparchus. This was backed up by various other Chinese astronomers in their own journals. And obviously today we can confirm that it is a star that is in our sky. But that's only the beginning of the story, because when it comes to its weirdness, a very random encounter led to that bit of information being discovered. David Fabricius was the one who made this unique discovery, but he wasn't looking for the star, rather he was looking at Mercury. On August 13, 1596, he was observing Mercury and tried to gather the distance between it and a star that he had noticed in the sky that was in a nearby constellation. The reason for this desire was quite simple. He had never noticed this star before, and when he tried to look for it in the maps of the stars that had been made by 1596, there was no trace of it. Now on Sun level, this is to be expected. After all, the earliest days of astronomy weren't known for their accuracy. Rather, they were known for wild speculation, incorrect analysis, and oftentimes not realizing that something was right there when they thought it was something else. Uranus, for example, was first thought to not be a planet but something else entirely, and as such it didn't get to planet status until a little while after its discovery. Anyway, getting back to Mira, the reason that Fabricius was so fascinated by it was that it appeared to be a rather interesting bright star, with a magnitude of 3. But as he kept watching it, by the end of August, a mere 2 weeks or so after first discovery, he noticed that the intensity of the star had actually grown to magnitude 2, which made it not just a very bright star, but one that was the brightest in the constellation it was in, which shouldn't have been possible based on what we know on stars and their movements and abilities, right? And it only got weirder as the months went on, because in September, it didn't get bigger and brighter, instead it shrank and got dimmer. Then by October, the entire star had vanished from the sky. Perplexed, Fabricius decided to not try and find the star as he felt it wasn't worth the effort for what was clearly not a new star. But then 13 years later, on February 5th, 1609, the star came back, and Fabricius was there to see it once again. And he wasn't the only one to notice, because a few years prior, Jonathan Bayer had noticed the star in the sky and put it in his famous star atlas. But because he wasn't with Fabricius in the decade prior, he didn't understand the importance of the star or what it could mean for astronomy as a whole. Between these two scientists, the world would soon know about Mira, and for many decades to come, scientists and astronomers would look up at it and try to figure out what was going on with it, especially since it was now a magnitude 4 star. This perplexing star in the sky got so much attention that it was eventually named Mira, because it's the Latin word for amazing, which is an apt description of the star given all that it can do, and the mysterious nature that it brought to the skies of Earth. If you're still not fully grasping what makes Mira so special, allow me to be a bit more basic in its description. During the vast majority of the year, the star Mira is so dim that you can't see it without a very good telescope and knowing where to look, okay? But as Fabricius and others noted, at certain times of the year, not only does it shine brighter, it becomes the brightest star in the Cetus constellation, which isn't something you'd expect from a star that isn't transforming into the next phase of its life. And just as weirdly, it'll go from being the brightest thing around to being dim once more. This cycle is one that continues on and off with both reliability and yet irregularity. Scientists can't always determine when it'll go bright or dim, but they can count on it to follow its cycle. Thus it is what we know as a variable star. That variable in this case is its brightness, if you couldn't tell. Over the course of 332 days, give or take, the brightness of the star will go from its most dim to 3.5 times brighter. For a star, that's an incredible change in regards to its brightness. In context, at its dimmest, it's known to be magnitude 10, which means it's a star that is basically invisible in terms of brightness. But then at its peak, it reaches magnitude 2, which made it the brightest of the constellation that it was in. Now, usually you'd expect some kind of pattern to this dimming and shining, but outside of it going up and down in terms of brightness, there isn't any pattern. In short, the star is unstable in its brightness, and that's why scientists can't simply determine where this brightness comes from at points, or how long it's going to stay alight or be invisible to the exact date and time. And at some points, the brightness of the star doesn't go fully bright or fully dark. During one cycle, it went from magnitude 10 to magnitude 2, the full ends of the scale. But in another, it only went from magnitude 9 to magnitude 5 before dimming once again. There is no serious pattern to this, nor rhyme or reason as to why it goes up and down inconsistently. However, there are those who believe they know a reason why we are able to perceive that brightness change. You see, when a star changes in brightness or pulsates, it doesn't just change in intensity of its shine, but also in its temperature. Think of it like a flashlight. If you hold it far away from your hand, you're not going to feel the heat from its light. But if you get closer to it, and thus the light is more intense, in this context, your hand will feel the effects of the heat. It's the same principle here. And as we all know, heat and temperature affect everything around you. In the case of Mira, it affects the atmosphere, and it's believed that when it's at its maximum magnitude, the atmosphere around the star becomes a lot clearer and thinner, and as a result, the intensity of Mira's star is conveyed. Or at least that's one theory that some believe is happening with the star. But believe it or not, there is still much more to discuss with the star, because in 1919, a new discovery was found. Mainly in that there isn't just one star called Mira. There is a satellite star called Mira B that circles that main star. And unlike Mira, it's a white dwarf star. Why does this matter? Because this particular white dwarf star is feeding off Mira, and that means it's having a direct effect on the star. But there's a twist in the tale here. You see, you'd think that this feeding would be noticed, or that the star would have been caught a lot earlier by Fabricius or Bayer or someone else, right? Except it wasn't, and for good reason. The reason it hadn't been discovered until 1919 was because Mira B only orbits its parent star once every 400 years. So that means since Fabricius found the star all the way back in 1596, that it hasn't had a full rotation around Mira. What's more, the distance between Mira and Mira B is much greater than the distance between Earth and our Sun. The distance between the Earth and the Sun is 93 million miles, which has now been classified as 1 AU, or astronomical unit. The distance between Mira and Mira B is 70 AU. Yeah, it's 70 times longer than the distance between the Earth and the Sun. However, despite the distance, Mira B does take after its parent in many aspects, including the fact that it too sees rises and falls in the intensity of its magnitude or shine. However, unlike Mira, we know why this is the case. In short, because the white dwarf is sucking mass away from the star, it has an accretion disk around it that it has to interact with. The inconsistent levels of mass that it gets allows the stars to shift in magnitude. However, also unlike Mira, the intensity of said shifts is much smaller. At its dimmest, the star gets to about magnitude 12, while at its brightest it only goes to about 9.5, which no doubt is a reason that scientists didn't notice it earlier, because Mira shines much brighter than Mira B by several intensities, so of course astronomers would notice that one first. And would you believe it? There is still more to talk about with this star. In 2003, a very special satellite known as the Galix was sent to observe Mira. And when it did, it noticed something very unexpected. Mainly, there is a trail of mass being left behind by the star, which because of its orbit and movement throughout the galaxy it's in, makes it appear like a comet's tail. To be clear, this is not the mass that is being absorbed by Mira B, it's something else entirely. Would you like to know the length of that tail? that would be 13 light years. If you need a little context as to how long that is, I'll help you out. If you were to draw a line from our Sun to the closest star that is next to it, you'd reach Alpha Centauri in about 4.2 light years. And it would take humanity with our current technology about 165,000 years to reach that star. So now times that by 3, and you can see that this tail is a very long piece of mass. One of the other reasons that this is unexpected is that it deals in direct contrast to how the other stars behave. Most stars follow the galactic rotation of the system it's in, which usually means a spiral pattern. But for Mira, it doesn't do that. Instead, it shoots through space at 130 kilometers per second. Because of that speed and the intensity of which it's shooting through space, the tail of gases isn't one to follow the gravity of the galaxy, but rather be shot back right behind the star. Oh, and the mass it's dispersing? If you take 10 years of it, you'd get about the mass of the Earth, and it's believed that to make this particular length of tail, it took about 30,000 years, which no doubt makes many wonder why it started to disperse the mass around then. So truly Mira is something special, and yet it is part of a club. For while it is one star that is unique in many aspects, it's a variable star, and there have been tens of thousands of variable stars found all over the universe. And because we know what to look for in regards to them now, we can search for them and find them wherever we look. And we have. More are found every year. None of them are quite like Mira, but that's okay, because stars like this one need to be alone to be truly special. And if there was a true lesson to be learned from this, it would be thus. The stars that fill up our skies and universe are still a mystery to us in many ways. We're still learning how they form, how they transform, the effects that they have on planets, and apparently even how they shine. It's easy to think of stars as simple balls of light, but the truth is far more complex and wondrous, which is why finding ones like Mira truly test our knowledge of them and create a burning desire to see what really makes them tick.